All right, IM1 classes. Today we're going to be talking about a skill that's going to help us as we move into the geometry portion of this class. So what we're going to be talking about is simplifying radicals. Let's actually talk about what a radical is. A radical is just a square root. All right, it's going to be helpful for you to know the perfect squares through 15. And we're going to go over those real quick, but a radical is just the square root. The square root symbol is, it looks like a division sign with the tail. What the square root means is when you take the square root of a number, it's what number do you multiply times itself to get the number in the square root. So it's the opposite of squaring something. So let's go through these perfect squares, what we call them, because they come out to whole numbers. So the square root of 1 is 1, because 1 times 1 is 1. I'm going to go down here. The square root of 4 is 2. That's because 2 squared is 4, or 2 times 2 is 4. Square root of 9 is 3, because 3 times 3 is 9. Again, that's how we're figuring it out. Square root of 16 is 4. Square root of 25 is not 2, it is 5. Back up here, square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14. And then square root of 225 is 15. These are the most common square roots that you're going to know, that you're going to need to know, just perfect squares 1 through 15. All right. If you can recognize these, your life is going to be a lot easier. All right. So the perfect square is super important. What we're going to talk about today is how to figure out how to simplify a square root without using a calculator. And this is what a lot of your work is going to require you to do. Require you to put your answers in simplified radical form is what it's called, and not just using a calculator to figure out the square root. So let's look at an example of how to do a square root of a number that is not a perfect square. So we have square root of 8. If you were to do the square root of 8 on a calculator, it comes out to 2.82. All right, but we're not using, we want to put this in what's called simplified radical form. So your answer is going to use a radical. So the most easy way to do this is, I call it the buddy system. What you're going to do is a factor tree. So you're going to take the number 8 and you're going to do a factor tree. So what two numbers multiply to get 8? So 2 and 4. Once you're down to a prime number, so 2 is a prime number, the only thing that multiplies to get 2 is 1 and 2. You don't have to continue the tree. But over here, we need to continue past 4. So what two numbers multiply to get 4? 2 and 2. All right, and so what you do is you're going to put those numbers back in the radical. So the 8 is the same as 2 times 2 times 2. So we're just looking at the bottom of the factor tree, the numbers at the bottom. All right. If it has a root coming off of it, you do not put it back in. So the 4 doesn't go in the factor tree because it has the 2's coming off of it. So here, now you look for pairs. We're finding pairs of numbers. So there's a pair of 2's. Actually, I'm going to do that. So there's a pair of 2's. For every pair of numbers, you put one of those on the outside. And then cross them out. And then that is the simplified. So then rewrite it without the numbers crossed in. So it's 2 root 2. And we're done. So that is the simplified radical form with square root of 8. And that's what we're going to be doing. So let's look at another example. Square root of 75. So first of all, do a factor tree on 75. So what are two numbers that multiply to get 75? That's 3 and 25. Two numbers that multiply to get 25 is 5 and 5. So now I have all prime numbers. So the factor tree is done. So the three numbers at the bottom of the factor tree go back in. So it's going to be 3 times 5 times 5. Look for pairs. So there's a pair of 5s. For every pair, one of those numbers goes on the outside, cross out the pair, it's no longer there. And so it's 5 root 3. Right, what's left? All right. I'm just going to do a whole bunch of examples for you. So square root of 50. So you can try this one on your own if you want to pause the video. I'm just going to go ahead and work straight through it. So 50 is 2 and 25, and then 5 and 5. Just for example, you might split this up differently. You might split up 50 as 5 and 10, and then 2 and 5. But if you look at the numbers at the bottom, so 2, 5, and 5, there's a 2, 5, and 5. So you get the same factor tree. You get as long as you're using numbers that multiply correctly, you'll get the same numbers at the bottom of your factor tree. Anyway, put it back in. So 2 times 5 times 5. Look for pairs. So there's a pair of 5s. For every pair, one of those numbers goes on the outside. Cross it out. So it's 5 root 2. Correct answer is C on that one. Another example, square root of 160. So this is going to be a long one. So 160. I'm going to split that up into 2 and 80. 80, then 2 and 40. 40 is 2 and 20. 20 is 2 and 10. And then 10 is 2 and 5. Again, you might split it up into something completely different, and that is fine. A lot of people would probably go 10 and 16. And then 10 splits into 2 and 5. And then 16 splits into 2 and 8. Or maybe you would do 2 and 4. I don't know. But then 8 splits into 2 and 4. Or excuse me, 16 would be 4 and 4. And then 2 and 2. But if you notice, there's 1, 2, 3, 4, 5 2s and 1 5. And then over here, there's 1, 2, 3, 4, 5 2s and 1 5. So you get the same numbers as long as you're picking, you're multiplying, you're splitting it up correctly. All right. So there's different ways to do that part. So like I said, there's 1, 2, 3, 4, 5 2s and 1 5. So we're going to look for pairs. So I have a pair of 2s. So for every pair, one of those numbers goes on the outside. Cross it out. Another pair of 2s. And so then it's going to be times, and you're going to multiply. If there's more than one pair, you bring out a number for each of those pairs and then multiply at the end. No more pairs, so those stay. And then the last step is then multiply what's left over. So 2 times 2 is 4. 2 times 5 is 10. So 4 root 10. All right. Next one, 54. So 54 splits into 2 and 27. 27 splits into 3 and 9. And then 9 splits into 3 and 3. So put that all in. So it's going to be 3 times 3 times 3 times 2. So 3 3s and 1 2. So look for pairs. Pair of 3s, one on the outside, cross it out, multiply what's left. So just a 3 on the outside, 3 times 2 is 6 on the inside. Next example, 150. So 150, you get 2 and 75, 3 and 25, and then 5 and 5. Again, yours might look different, and that's okay. So it's going to be 2 times 3 times 5 times 5. One thing I have not mentioned is when you're writing these numbers in, put them in order, smallest to biggest. If you need to, if you have a bunch, you need to check it out. If you put them in order, it's going to make it easier to find the pairs. So that's just a good idea. You're looking, so it's going to be a pair of 5s, one on the outside, and then multiply what's left. So it's 5 root 2 times 3 is 6. So the correct answer is B on that one. Next example, square root of 30. This is a good one to do. So 30. Oh. So 30 splits into 2 and 15. 15 splits into 3 and 5. All prime numbers, so you put in, so 2 times 3 times 5. No pairs. So when there's no pairs, you can't keep anything, you can't take anything out. You just have to multiply what's left over. So square root of 30 is as simplified as it gets. You just leave it as square root of 30. Last one, square root of 18. So this is an easier one. So 2 and 9, and then 3 and 3. Put those in. So 2 times 3 times 3. Look for pairs. So there's a pair of 3s. One on the outside, cross them out. So it's 3 root 2. What's left? All right. The assignment is on Delta Math with this lesson. So get the assignment done. If you have questions, let me know. Other than that, we will see you guys next time.